Hello, this is Srikanth Reddy, P. lecturer in Electronics Communication Engineering, working at Government Polytechnic, Jogpet. Today's topic is inductors. The main objectives are introduction about inductors, classify inductors, symbols of different types of inductors, list the specifications of inductors, list and explain the important parameters of air-cooled inductors, explain the terms stay inductance, list the applications of AF and RF chokes, list the common faults in inductors. These are the objectives. Introduction. Inductor or coil or choke is an electromagnetic device consisting of a conducting wire wound in a cylindrical or spiral form to obtain concentrated magnetic flux. The base on which the coil wound is known as core. The core may be a magnetic material such as iron, ferrite, or air. That means here inductors. Inductors is a passive component. Passive component means the components are basically divided into two types: active components and passive components. Active component means the components which delivers the energy or power to the other devices. These examples of active components are voltage source, current source, etc. Passive components, the components which absorb the energy or power, is called passive components. Examples of passive components are resistors, inductors, capacitors, etc. Here inductor is a passive component. So inductor or another name is also called coil or choke. Inductor or coil or choke is a electromagnetic device which consisting of a conducting wire wound in cylindrical or spiral shape to obtain concentration in magnetic flux. So the inductor is a cylindrically or spiral form. The base which have wound is called as core material. Core. The core material may be magnetic material or non-magnetic material. Examples: magnetic materials are iron, ferrite. Non-magnetic materials are air core or plastic. These are the inductor. We show the inductor symbol. Yeah, different types of inductor symbols are there. We are used air core inductor, and the inductor indicated by H symbol, and the units are Henry. Next topic, classify inductors. According to we have mainly classified into many more ways according to the core material used. According to the core material used, we have classified into three types: air core inductors, iron core inductors, ferrite core inductors. Air core inductor, it consists of number of turns of wire and air inside the coil. An air core inductor has least inductance for a given number of turns and core length. Means the wire wound which called as core. The turns of core is called is made with mm, uh, made with inside the air of the coil. Core inductor is less inductors. This value is very less compared to other inductors. Iron core inductors. In these inductors, the wire wound is over a solid or laminated iron core. So the iron core inductors are made with iron, laminated iron, which is base or core. Here, putting iron inside the inductor has the effect of increasing its inductance as many times as relative permeability of iron. In order to avoid eddy current, the core is laminated. That is, it is made up of the thin iron lamination pressed together but insulated from each other. Sometimes such inductors is also called choke. These inductors also called as choke. We call the core material is laminated by iron in this way, reducing it to avoid the eddy current loss. Ferrite core inductors. In this case, coil of wire is wound on a solid core made with of highly ferromagnetic substance called ferrite. Ferrite core has minimum eddy current loss. So here the ferrite core inductors are made with ferromagnetic substance of core. Base is called as base is made with ferromagnetic material. These are the three types according to the core material. These symbols are shown in these numbers. Air core inductors, iron core inductors, ferrite core. Air core inductor simple inductor symbol, iron core has inductor with two lines, ferrite core has inductor symbol with dash and lines. These are three different types of inductors shown. Next way, according to the frequency of operations. According to the frequency of operations, inductors are classified into two types: audio frequency coils, these are called AF coils; radio frequency coils, RF coils. Next, according to the method of winding, the inductors are classified into two ways: single layer coils, multi-layer coils. According to the type of operation, these inductors are called into fixed coils and variable coils. These are the classifications of inductors. The symbols of different types of inductors are there: air core inductor symbol, iron core inductor, ferrite core inductor also already explained. Variable inductors, this arrow indicators variable indicators means the inductor value is varied. Next one we indicate tapped coil inductors, three arrows indication towards the inductor, and movable ferrite core inductors. So there is variable inductors which are ferrite made with ferrite material. These are the different types of inductors. These are the different types of inductors symbol. Next topic, list the specifications of inductors. The specifications of inductors are given below: inductors value, insulation resistance, power rating, temperature coefficient of inductance, core material, type of winding, moisture resistance, high temperature, load life. These are the specifications of inductors. List and explain the important parameters of air core inductors. The term air core inductor describes an inductor that does not use a magnetic core made of a ferromagnetic material made of ferromagnetic material. Here the term air core inductor describes an inductor that does not use a magnetic core made of ferromagnetic material. The term air core refers to as coil wound on a plastic, ceramic or other non-magnetic forms, as well as those that have only air inside the winding. So, air core inductors are made with non-magnetic materials or non-ferromagnetic materials. In this, the core is made with plastic or ceramic or non-magnetic materials. The important parameters of air core inductors are: inductance value is very small, that is microhenries to microhenries or microhenries. Inductance value is stable under operating condition. Any operating condition, inductance value is stable. Generally used for high frequency. These inductors are generally used for high frequencies. This inductor self capacitance is low. The temperature coefficient of inductance is low. Cost and size appreciable, reasonable. These are the important parameters of air core inductors. Explain the term stray inductance. The unwanted inductance associated with current carrying conductor or conductor is called stray inductance. That means the unwanted inductance associated with current carrying conductor or conductors means any conducting wire which has unwantedly inductance associated. That's why this inductance value is called as stray inductance. The stray inductance is normally insignificant in DC circuits and low frequency AC circuits. However, stray inductance can be produce undesirable effect on the performance of high frequency AC circuits. It is because the value of stray inductance can be significant in high frequency circuit. The stray inductance can be minimized by keeping connecting wires as short as possible. So, the stray inductance value is very less, which are the unwanted inductance in the general circuits. List various core materials used in the construction of inductors. Here we also used inductor, is sometimes also called or sometimes used in transformer. So transformer is one of the applications of inductors. The transformer working mainly depends on its core design. So here the magnetic core is heart of the transformer. The silicon steel alloys are commonly used for the core manufacture for the transformers at power frequencies from 60 to 100 Hz. Here different types of core metals used in transformers are inductors, silicon iron alloy cores, nickel iron alloy cores, ferrite cores, powdered iron cores. These are 4 different types of core materials used in inductors or transformers. List the applications of AF and RF chokes. Applications of AF chokes. These AF chokes used in DC regulated power supplies for providing few DC signals, and these used for filter circuits in TV receivers. These filters used in filter circuits in radio receivers, used as modulation chokes in transformers or transmitters. These are used in relays. These are used in audio and power transformers. These are the applications of AF chokes or audio frequency chokes. Applications of RF chokes, radio frequency chokes. These are used in radio receivers. These are used in TV receivers. These are used in FM receivers. These are used in oscillators. Oscillators are used to generate the desired frequencies. These are used to select the desired RF signal and reject all other frequencies in communication receiver. Just like we can use in filters. These are the applications of AF and RF chokes. Generally used in receivers, mainly TV receivers or radio frequency, radio free receivers, transmitters and power transformers, oscillators, filters. List the common faults in inductors. The most common troubles is on coil or transformers or open winding and short across secondary winding. These are some of the faults. That is open coil. If the winding of the coil is broken at any point of the coil is said to be open. An open coil reads infinity resistance when its continuity is checked with an ohm meter. When the open circuit is inside the winding, it is usually not practical to repair the coil and the entire unit is replaced. In some cases, an open connection at the terminals can be replaced. So, open coils can be by two ways we can find out. One is open coil broken at outside the coil, so we can show it. So the coil shows the infinity inductance value or resistance value. If the coil is open at inside the core material, we cannot find it totally, it can be replaced. So open coil is one of the fault in inductors. Open primary winding. When the primary of the transformer is open, no primary current can flow and there is no voltage induced in any of the second windings. If the primary winding is open, no induced EMF in secondary coil or open secondary winding. When the secondary of the transformer is open, it cannot supply power to any load resistance across the open winding. If the transformer has several secondary windings, however, an open winding in one secondary does not affect transformer operation of the secondary circuits that are normal. So if the second coil is open, then the current supply is not, they cannot supply power to the load, any load resistance. Next one, short across secondary windings. If excess current flows in the primary, the transformer gets heated and burns out of primary winding. The reason is that a large secondary current has strong field that opposes the flux of the self-induced voltage across the primary, making it draw more current from the generator. So short across secondary winding is primary. If the excess current flows in the primary, the transformer gets heated and burns out primary winding. The reason the large secondary current has strong field that opposite to the flux of the self induced voltage across the primary main. So these are the common faults in inductors. The overall review of today's topic is in introduction about the inductors. Inductors means the wire wound in it is a conducting wire or it is a electromagnetic device are consisting of conducting wire wound in cylindrical or spiral shape. So the inductors mainly it is a positive component, and the inductors indicated by H symbol. The units of inductors are Henry. Classify inductors. Inductors are classified into many ways. Here, depending on the core materials, air core, iron core, and ferrite core, depending on the operation, fixed inductors and variable inductance, depending on the frequency of operation, audio frequency inductors and radio frequency inductors, depending on the method of winding, single layer winding and multi-layer windings. Next, list the specifications of inductors. Here the specifications are inductance value, insulating resistance, power rating, temperature coefficient, core material, type of winding, much resistance. List the applications of AF choke and RF chokes. Here the AF chokes are radio frequency chokes. We can have applications. We can use transmitters, audio frequency receivers, TV receivers, filter circuits, radio circuits, and relays. We can use power audio and power transformers. Applications of RF chokes. We can use radio receivers, TV receivers, FM receivers, and oscillators, and select desired signals and reject all wanted. This means filters. Different types of materials used in air inductors. Inductors we were made with different core materials: iron, silicon iron alloys, or iron ferrite core, or nickel iron alloy, and powdered iron. These are different types of made with core materials. And common faults can used in open coil and open primary winding and secondary winding, short of secondary winding. These are and stay inductance. Stay inductance is the unwanted inductance which are measured in any circuit. This inductor value is very less. It is measured in very low frequency. It can be effective in low frequency circuits. When a very high frequency circuits is negligible. These are the today topic review. Thank you.